Okay, first, you should have already worked through this practice quiz and done what you can. Tried to do all of them, and now we're looking at to see what you should have done, hopefully what you did do. Alright, so number one says the negative square root of 0.64. Okay, well, I already know that since it's negative, my answer is going to be negative. Now I don't have to worry about that negative sign anymore. I can just worry about the square root of 0.64. Okay, now I can just use my calculator for that. Or maybe you notice that this is a 64. We know the square root of 64 is 8. So this should be the square root of 0.64 is 0.8. Or if you use your calculator, okay, you don't put the negative in. Okay, you just do the square root of 0.64 and it will give you 0.8. And you know that since it asks for the negative, you give the negative. Alright, and for number two, you definitely don't need a calculator for this one. This one also asks for the negative square root, this time the negative square root of 4. So the answer is going to be negative, since that's what it asked for, and the square root of 4 is 2. So that's the answer to number 2. The negative square root of 4 equals negative 2. Alright, now, number 3 and 4 ask us to find the value of x and then classify the triangle as acute, right, or obtuse. Okay, now I have to find the x value first to do that, because I don't know what all three angles are until I find that third angle. So looking at number 3, how many degrees are in a triangle? The sum of all the interior angles, since it has 3 sides, is 180 degrees. So if I add all the angles up, I should get 180. So I have 53 plus 30 plus x equals 180. Alright, so that makes x plus 83 equal 180. And so now I'm just solving this algebraic equation. I need to move this plus 83 to the other side. So I do a minus 83 on both sides. And that gives me x equals 97. Okay, so that angle is 97 degrees. Okay, so now I know this triangle has a 30-degree angle, a 53-degree angle, and a 97-degree angle. Okay, now that makes this an obtuse triangle. Now, if you look at the triangle, it doesn't look obtuse. It looks like it would be acute. And if you answered it before you found x, you would have probably said acute. But look at the x angle. It's 97 degrees. That's bigger than a right angle. That's an obtuse angle. So that makes it an obtuse triangle. Okay? And while we're naming it, we can go ahead and say that it's also scalene, because none of the angles are the same. That means none of the sides are the same either. Alright, and then for number 4, I have to do the same thing. Again, I have 3 angles because it's a triangle. I know this one's 41. This one has a little square. That means it's a right angle, so I know it's 90. And this one's x. So I have x plus 90 plus 41. And all of that should equal 180 degrees. So I've got x plus 131 equals 180. Alright, so I need to move the 131 to the other side, so I subtract, and I get x equals 49 degrees. So this angle is 49 degrees. So now I know I have a 90, a 41, and a 49, so that makes this a right triangle. Okay, and again, while we're naming it, we can go ahead and say that it's also scalene, because none of the angles are equal, so none of the sides are equal. Alright, now looking at number 5. This time, number 5 asks you to find the length of the hypotenuse of the triangle. Okay, which means you're trying to find C. How do I know that's the hypotenuse? Because it's across from the right angle. Okay, and then also it says to round to the nearest tenth. Okay, so how do you find missing links in a right triangle? How do you do pretty much anything with a right triangle? With the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. Alright, so I have A, I have B, I don't have C. Now, it doesn't matter which one you call A or B. It doesn't really matter. As long as C is the hypotenuse, then you're good. Okay, so A is -2, B is 6, and C is just C, because I don't know what it is. Okay, so all I did was plug in the A value for A, the B value for B, and I don't know what C is. Notice, it doesn't matter if it's negative or positive, I can still plug it in. Because think about this, whether it's negative or positive, what answer am I going to get here? Well, either way I get 4, because 2 squared is 4 or -2 squared is 4, so it really doesn't matter if these links are positive or negative, because when you square them they're going to be positive. Alright, so then plus 36 equals C squared. So now 4 plus 36 is 40, so 40 equals C squared. So I have to take the square root of both sides, so I get C equals the square root of 40. But it told me to round to the nearest tenth. Now, this is an exact answer. I like this answer because it's exactly the length of C. But it told me to round it, so I'm going to go ahead and do that. So I'm just going to type this in my calculator and then round it to the nearest tenth, which would mean that C equaled 6.3. So C equals 6.3, so this is 6.3 feet long. Alright, now number 6 and number 7 are very simple because they're an algebraic equation and there's only one thing to get rid of on both of them, and that's a square. Well, how do we get rid of a square? We square root. Okay, so on number 6 I have to take the square root of both sides, and that gives me C equals plus or minus 13.7 because it said to round to the nearest tenth. Now, why did I get plus or minus? Okay, because I took the square root. Okay, the problem didn't tell me to take the square root, I took it, and so I have to take both of them. Because think about it, if you checked your answer, if you squared 13.7, you'd get 187, and if you squared negative 13.7, you'd get 187. Either way. So it's positive or negative 13.7. Alright, same thing with number 7. I have to square root both sides. So n equals, and we should know the square root of 400 is 20. So the answer is n equals plus or minus 20. Alright, now number 8 is kind of like number 5, except for this time I'm missing the A value. Okay? It says that C is a hypotenuse, so that lets me know it's a right triangle. So I know that I have a triangle just like this one, except for I know that B is 12, C is 44, and I just don't know what A is. So again, I'm going to use the Pythagorean theorem. Okay, so A squared plus B squared equals C squared. See, I've already plugged them in. I don't know A. B is 12. C is 44. Okay, so now I'm going to simplify. A squared plus 144 equals 1,936. Now I have to get the A squared by itself, so I've got to move the plus 144. So I need to subtract 144 from both sides, and that gives me 1,792 equals A squared. So now, looking back at 6 and 7, how do you get rid of a square? you square root it. So I have to square root both sides, and that gives me A equals 42.3. Now, how come I didn't do the plus or minus here? Well, that's because this is a distance. Okay, so I can just take the positive one here because this is talking about a distance, how long something is. Okay, so I can just take the positive answer here. I don't have to take both. If it's just an equation and you don't have any context, you have to take both. If you're just talking about a distance, you can just use the positive. And I rounded to the nearest tenth because it told me to do so. Alright, now 9 and 10 is just asking me if it's rational or irrational. Alright, so number 9, 0. Rational or irrational? Well, all rational numbers can be written as fractions, and irrational numbers can't. So 0 is rational because I can write 0 as a fraction. 0 over 1 equals 0. Alright, now number 10, remember when I told you where most of your irrational numbers come from? There are square roots that aren't perfect squares. Well, 17 is not a perfect square, so if you try to take the square root of 17, you get an irrational number. Okay, any square root that's not a perfect square is irrational. It doesn't even matter if it's negative or positive, that's irrelevant. Okay, because of the 17 not being a perfect square, if you take the square root of it, automatically irrational. Alright, now, number 11 and 12. Notice here, it says do not use a calculator, which means you're going to have to show your work or you're not going to get any credit. Okay, so here's what your work should look like to receive credit. Okay, I'm looking for the square root of 20.6. Well, I need to find two perfect squares that are on either side of that. So I have the square root of 16 and the square root of 25. Well, I know that the square root of 16 is 4 and the square root of 25 is 5. So I know this is going to have to be somewhere in between 4 and 5. Well, this looks like it's pretty much right in between 16 and 25, so I'm going to pick the number that's right in between 4 and 5, and that's 4.5. So my estimation for the square root of 20.6 is 4.5. Now, again, if I don't see this and this, then I'm marking it wrong, because this is how you estimate. So you need to show me what you did, what you were thinking. Alright, and number 12. I've got the square root of 5. So I need to come up with two perfect squares around 5. Well, that's the square root of 4 and the square root of 9. The square root of 4 is 2. The square root of 9 is 3. So I know this has got to be somewhere between 2 and 3. Well, 5 is a lot closer to 4. So I'm going to pick a number that's closer to 2. So I pick 2.2. So I'm going to approximate square root of 5 as 2.2. Alright. Now, number 13 looks like it might be kind of complicated. You've got to find the length of CD. That's this line right here, to the nearest tenth of a centimeter. Well, how are you supposed to do that? Well, first I know that since it's a square, that these are also 9s, right? That side's 9, that side's 9, that side's 9, that side's 9. Okay, and I also know that this is a right angle. Now, when you look at this picture, do you see anything we've been doing? Well, you should, because I see a right triangle. And what am I looking for? I'm looking for C. This is the exact same problem that we've already done, just with different numbers. It's a right triangle, you're missing the hypotenuse. Okay, so I do a squared plus b squared equals c squared. Simple as that. Okay, because this is my a, this is my b, and I don't know c. So I've got 81 plus 81 equals c squared. So that's 162. And then to get rid of the square, I have to square root it. So I get that C equals 12.7 because I rounded to the nearest tenth of a centimeter. So here's my final answer. CD equals 12.7 centimeters. Okay. So this is just Pythagorean theorem, but you had to recognize that there was a right triangle. Otherwise you didn't know what you were doing. Alright. Now let's look at number 14. Okay, number 14 says you have a square tile that has a line connecting the diagonal corners, which seems pretty much like the last problem. Okay, if the sides of the tile are 14 inches, what is the length of the diagonal? Okay, so we've got a square. We've got a diagonal. There's the line going across it. We know that each side is 14 inches. Okay, we also know that that's a right angle. So this looks almost exactly like the last problem. They're just 14s instead of 9s because I'm still looking for C, and it's the hypotenuse. So I'm just doing a squared plus b squared equals c squared. Well, 14 squared is 196. 14 squared is 196. 196 plus 196 is 392. So to get rid of the squared, I square root both sides, and I get that C equals 20 inches. Now, it wasn't exactly 20, okay, but notice it said round to the nearest inch. Well, this was slightly less than 20, right? Because the square root of 400 would have been exactly 20, so it's a little bit less than 20. But since it said round to the nearest inch, I know that it's 20 inches. So the length across that tile is 20 inches long. Alright, now I'm going to only do the even problems on this page. I'll do the odd ones on the next one, okay, because there's not really a lot of room here. Alright, so this time I'm going to be looking at 16. I'll do 15 in a minute. Alright, so we have a 30-foot ladder against a building that reaches a window 15 feet above the ground. Okay, and the question is, how far from the building should she place the base of the ladder? Okay, she's trying to put a 30-foot ladder up against a 15-foot high window. And well, the first thing I have to do is draw a picture, because I may not be able to see what's actually going on. So I've got my building, I've got my ladder, I've got my ground. Okay, now what do I know? I know that the ladder is 30 feet long. I know that the building is 15 feet tall, or at least the window I'm trying to reach is, so for my purposes the whole building can be just 15 feet tall. And what am I looking for? I'm looking for how far should the ladder be from the building. Well, the building, at least if it's built right, is going to be a right angle, so that makes this question mark my A. So I have A squared plus B squared equals C squared, because here's my right triangle. The building, the ladder, and the ground makes a right triangle. So I have A squared plus B squared equals C squared. Now let me simplify that. I get A squared plus 225 equals 900. So now I have to get the A squared by itself. I can move the 225 over by subtracting 225. And that gives me A squared equals 675. So to get rid of the squared, I square root it. And I get A equals 25.98. Now, So I'm going to go ahead and round that one as well, and I'll say that it needs to be 26 feet away from the building. Okay, notice I didn't leave my answer as A equals. I answered the question. How far from the building should she place the base of the ladder? 26 feet away. Okay, I probably could have even made that better and said she should place the ladder 26 feet away from the building. Okay, but you have to answer the question, not just answer what you did. Alright, so now, again, we're going to skip 17. We'll do that one in a minute. We're going to do 18. So the top of a 10-foot ladder is placed against a wall so that it reaches the top of the wall. If the bottom of the ladder is 4 feet from the wall, how high is the wall? Okay, similar diagram. We still have a building, a ladder, and the ground. Okay, we know the ladder is 10 feet tall. This time we know that it's 4 feet away from the bottom of the building, or the wall in this case, but we don't know how tall the wall is. Okay, well this time it's still a right triangle. Okay, but this time I know C and I know A. I can find B. Okay, so I have A squared plus B squared equals C squared. Well, 4 squared is 16, 10 squared is 100. So now I have to move the 16 to the other side, subtract 16 from both sides, and I get B squared equals 84. So to get rid of the squared, I do the square root. And I get B equals 9.165. Okay? So I'm going to say that the wall is 9.2 feet tall. Okay, again, notice I didn't leave my answer as B equals 9.165 or even B equals 9.2. I wrote my answer as 9.2 feet tall, or I could have probably even said the wall is 9.2 feet tall. Alright, now let's look at the odds on that page. Okay, so we're going to look at number 15 this time. Alright, it says the area of a square is 25 square units. The length of the side, what is the length of the side of the square? So again we have a square, but this time we know the area. Well, area of a square is the length of the side squared. That's why we call that squared. Okay, so I have 25 equals s to the second power. Well, how do I get rid of the squared? I square root it. So I know that this side equals 5. Okay, and if you want to think about it as a shortcut way, what kind of square gives you an area of 25? And that's a 5 by 5. Okay, so the length of this side is 5. Okay, 5 units. It doesn't give us a unit, but it just says unit, so you could probably say 5 units long. Alright, number 17. We have a room. This time it's a rectangle, 25 by 15, and we're trying to find the diagonal. Again, it's a diagonal, which probably means it's going to make what? Yes, a right triangle. Okay, so I have a 15 by 25 room. The diagonal is going across it, and I see a right triangle. So I'm looking for C. So I have A squared plus B squared equals C squared. So that's 225 plus 625 equals C squared. So 850 equals C squared. And how do I get rid of a square? I square root it. So C equals 29.15. Well, it said round to the nearest foot. So that means that is 29 feet across that room. Okay, now we're going to look at 19 and 20. Alright, number 19 just asked me to classify the triangle by its angles and its sides. So first I'm going to look at the angles. I've got a 45, I've got a 90, I've got another 45. Well, if I've got a right angle, then that makes a right triangle. Okay. Then I'm going to look at the sides. Okay. I notice I've got congruent marks. That means two of these sides are the same. But also, I've got two angles the same. Two angles the same means isosceles. Two sides the same also means isosceles. So this is a right isosceles triangle. Alright, now number 20. Number 20 asks you which numbers represent measures of the sides of a right triangle. In other words, if these three are the sides of a triangle, which one of these triangles is a right triangle? Well, anytime you're dealing with right triangles, you're always looking at the Pythagorean theorem. Okay, this is what tells you it's a right triangle. When you don't have a side, you figure out what would make this true because it's a right triangle. If you've got all the sides, you just see if this is true or not. Okay, so I'm going to test out A. Okay, if this was a triangle, it would be 10 squared plus 15 squared equals 17 squared. A squared plus B squared equals C squared. Remember, C has to be the biggest. Alright, so that gives me 100 plus 225 plus 289. Well, that's 325 equals 289. That's not true. So A is not a right triangle. Alright, I'm going to test C out now. Okay, 8 squared plus 15 squared equals 17 squared. So 64 plus 225 equals 289. Well, 64 plus 225 is 289, and 289 does equal 289. So C is the correct answer. Okay, so if it's a right triangle, then the Pythagorean theorem has to be true. Now, it'd probably be a good idea to test these other two out and make sure they're not too, because maybe I messed up. Okay, but if this is true, then this is a right triangle. Okay, now you need to make sure that you review this, work on all your past assignments, because on Tuesday we are going to have a review day, and then on Wednesday we will be having our quiz. So you need to make sure that you are preparing for it.